All right, so here we are. We're going to talk about functions, and just a quick introduction to that. Some things that we need to know before we talk about functions, though, is domain and range. So that's what this slide's all about. We're going to get into that, but you should pause the video and write this stuff down. Okay, so taking a look at these, here we have our I can statements, identifying a function from tables, a set of ordered pairs, and a graph, and then identifying a domain and range from a graphed equation. That's what's going to be this whole activity is going to be all about that. So let's talk about domain and range. Domain is just simply this. It's the set of the first coordinates. So we're looking at ordered pairs and coordinates. We're talking about the x, comma, y values. The domain is a list of all the x values here. We can find those x values in tables, on graphs, and especially in our ordered pairs. And what's kind of new is our mapping diagrams. The range is just the set of the second coordinates. That's your y values. So let's take a look at that and what that means here. Mapping diagrams just look like this. What's in my red box here? It's just use the list, the domain, the list of x values, and the range, all the y values, of a function in numerical order. And they're usually listed as like 1, 2, 3, 4, 1, 2, 3, just from least to greatest. And what's cool about that is you don't see any repeats of numbers, and so that kind of helps keep us organized. Here we have the ordered pairs, and that actually matches our mapping diagram. So if we were to go through all of our x values to list all the domain, we have right here a 1. So we have a 1 in our mapping diagram. We have a 2. So we have a 2. We have a 3 as an x value. So there's another domain value. And then a 4, which is our last domain value. And then a mapping diagram just simply does this. It maps all the x values to the y values. So you can see here, 1 should be mapped to the range value 3. And so we have an arrow going from 1 to 3. We also have the 2 in the domain mapped to the range value 3. We have the domain value 3 mapped to the range value 2. And then the domain value 4 mapped to the range value 1. And that's all a mapping diagram does, is it shows the connection between the two, kind of like an ordered pair does here.
So to sum up, you're saying that the domain and range of a function are the x and y, but the difference when listing the domain and range is that the domain and the range values are never repeated.
Yep.
Okay.
Yeah, and so over here in the mapping diagram, we don't see the repeats. So for instance, right here you see the y value listed twice, but over here in the mapping diagram, it's only listed once, but we just have 2 arrows pointing to it because this x value 1 is mapped to 3, but so is 2. So we don't see any values repeated over here for 3. We don't have another 3 down here. It's just mapped to it twice from 2 different numbers. Okay. That's domain and range. List of x values, list of y values. All right, so here we have a bunch of different ways to list off x and y values. We got tables, we got ordered pairs, graphs, a mapping diagram, and simply we're just going to list the domain and the range separately. Because these are all different points, they're not connected, they're all separate from each other, we are going to use set notation. And generally what we'll do for domain is we'll just write D and then our set notation, which is those funky chicken brackets, those curly brackets, and then we just list them off from least to greatest. But it's really important to remember that we do not repeat our values. So when we're going through our domain, we're just looking at our x values, so 1, 2, 3, 4. As you can see right here on our graph, we have the point 1, we have the point 2, we have the point 3, and we have the point 4. These are our domain values. Even though 5 is listed down here, there's no ordered pair above it. So that's not going to be a domain value. Same thing here, our mapping diagram makes it really easy to see our x values. You can also see your x values here on your table. You can also see all your x values up here on your ordered pairs. But to list them, we're just going to list them from least to greatest. So 1, comma 2, comma 3, and comma 4, funky chicken bracket, curly bracket to close up the domain. Again, just like the definition said earlier, the range is a list of all the y values. So we're going to go look for all those y values. If you look here on your graph and all that, our y values can be found here from our table. Y values could be found up here with our ordered pairs. But our y values could also be found from our graph. Remember, we're talking about y values. This point's y value is at 1. This point right here is at 2. This one, and both of these are mapped to 3. Remember, we don't list 3 twice because we don't want to repeat those values, much like the mapping diagram here shows us. We're going to close that up with a funky chicken bracket. Okay. All right, let's try it and move on. Let's try one out. Why don't you go ahead and pause the video and try this one out. Just list the domain and range. All right, so let's take a look at this. We have a domain. Remember, we list the domain out with D, and we're going to list out the domain here. The domain is a list of all the x values, and from a mapping diagram, that should be really easy to find. There's my domain values. Very simple. 1, 2, 5, and 6. And I am going to double check. Are those listed from least to greatest? Yes, they are. Also, are there any repeats? Because I don't want to list any repeats. So that looks good. A mapping diagram shouldn't have any repeats in it anyway. Let's go take a look at our range values here. Those are all of our y values. We're going to say, hey, we're looking at the range. All my range values from least to greatest. Looks like they're already listed here, nice and easy for me, as -4, -1, and 0. Don't make fun of my funky chicken bracket.
He's struggling.
Yeah, maybe
That's
a
a
little bit.
butt cheek.
All right, go ahead and pause the video for this one. See if you can list the domain and range. All right, so let's list the domain. The domain, again, is all of the x values. So let's get that funky chicken bracket here. And we're going to go look through our domain values. Those are our x values. So here's an x value, another x value, another x value. And I want to list those from least to greatest. So let's go from -1, and then -1 again. Oh, wait, I don't list -1 twice, so I'm just going to leave it as -1, and I'm going to go 0, and then we're going to go to 2.
Change
there-
the color. It's boring.
Those are my domain values. Let's go list my range values. There you go, Mr. Craig. You like green?
Yes, I just don't like using the same color.
All right, range values are all the y values. So let's look at our y values, -4, -1, 8, and 8. You notice I have a repeat. That's okay. We just don't want to list it twice, okay? So we got -4, we got -1, and then we have 8. Don't write 8 again because we don't want to list it out twice. We're just saying, hey, oh, this is my weird funky chicken bracket
You just
again.
can't do the right side.
Just can't do it. All right, so there we go. That's our y
Problems are real,
values.
student.
Hey, now. All right,
Problems are
one
real,
more time.
students.
Go ahead and pause the video. Try this one out. All right, let's list the domain and range. Remember, the domain is a list of our x values. Yeah. There, I got a good funky chicken bracket. So my x values are found right here. All my x values. See, I'm going to go from the smallest one. We got -5, then -3, then 0, and then 2, and then
Another 2,
but I don't list it out. Here's my other color.
Thank you.
You're welcome. All my y values, we're going to list the range out. Well, this is how I normally start it, and I'm going, oh wait, it's just 2. That's it. Only 2. Why about y values here? My range values, only 2. So that's it.
Mr. Nelson, do I have to put set builder notation if there's only one value?
Yeah, you don't actually need set notation. If you just want to say, hey, the range is 2, that's fine as well. It's kind of like when we were solving absolute value equations. If you've got 2 solutions, you have to list them in set notation. But if you had 1 solution, then you didn't have to. You can if you want. It's more writing. But if you're just kind of getting set up for it anyway, and then you look and you go, oh, there's only 1 value, it's okay to use them. No problem there. But that's it for this video. Go ahead and try the problems just below this. Do your best. Thanks.